Mars has long been a focal point of scientific debate, primarily because of its striking similarities to Earth in its early history. Today, Mars is a barren, waterless desert, but abundant evidence suggests that it was once a water-rich world, much like Earth. This raises the tantalizing possibility that Mars may have been an ideal environment for abiogenesis, the emergence of life, and in some respects could have been even more conducive to life than Earth was at the time. While we still know very little about how life begins, one thing is clear: liquid water is essential. Water is the solvent for the chemistry of life, and Mars had plenty of it, as evidenced by its ancient river channels, water-altered minerals, and other geological features. But water alone isn't enough. Most models of abiogenesis also involve volcanism and the internal heat of a planet. On Earth, life may have begun near hydrothermal vents in the ocean or in hot springs on land. Mars had these features too, as confirmed by rovers and experiments. In fact, every life detection experiment conducted on Mars has yielded intriguing, albeit controversial, results. Some have even hinted at the possibility of past, or even present microbial life. However, none of these findings have been conclusive. We are now entering a critical period in Mars exploration. With humans likely to set foot on the planet within the next few decades, possibly sooner, we are running out of time to conduct sterile life detection experiments without contaminating the planet with Earth's microbes. If we are to send humans to Mars, it's crucial to understand the planet's biological history and potential hazards, such as pathogens that could endanger astronauts or be brought back to Earth. Let's explore some of the most compelling hints that Mars may have harbored life and why it's essential to investigate further before humans arrive. The red planet's mysterious color. One of the first clues that something unusual happened on Mars is its red color, visible even from Earth. Mars's reddish hue is primarily due to iron oxide, or rust, which covers its surface. Interestingly, Mars is about twice as rusty as Earth, despite Earth having far more oxygen in its atmosphere. On Earth, the Great Oxidation Event, driven by photosynthetic life, caused widespread rusting and a mass extinction. But Mars, as far as we know, never had significant amounts of oxygen. So, how did it become so rusty? The answer lies in the differences between Mars and Earth. Mars is smaller and less geologically active, meaning more of its iron remained near the surface rather than sinking into the core. Additionally, Mars's magma may not have been hot enough to break down iron oxide formed early in its history. Some models suggest that Mars inherited oxygen from the solar nebula, which reacted with iron to create rust. However, this process doesn't explain why Mars is so much rustier than Earth, where rusting only became widespread after the rise of photosynthetic life. This raises the question, could life have played a role in Mars's rusting? While it's possible, the evidence remains ambiguous. The Viking landers' controversial experiments. In the 1970s, NASA's Viking landers conducted a series of experiments to search for life on Mars. The most famous of these was the labeled release experiment, which detected something in the Martian soil that appeared to metabolize nutrients. However, the results were controversial, as other experiments on the landers failed to confirm the presence of life. Scientists involved in the Viking missions have maintained that they may have discovered microbial life, but the debate remains unresolved. The controversy highlights the challenges of searching for life on another planet. The experiments were designed based on our understanding of Earth's biology, which may not apply to Mars. If we are to send humans to Mars, it's crucial to repeat these experiments with modern technology and better methodologies to resolve these questions once and for all. Martian meteorites, clues from space. Over 200 meteorites originating from Mars have been found on Earth, and some of them contain features that could be evidence of past life. The most famous of these is the Allen Hills 84001 meteorite, which contains microscopic structures resembling fossilized bacteria. However, these structures are much smaller than any known Earth microbes, leading to debates about whether they could be evidence of nanobacteria, a controversial concept in microbiology. Other Martian meteorites, such as Nakhla, Shurgadi, and Yamato 000593, also show signs of water alteration and contain organic molecules. While these findings are intriguing, they are not conclusive. Organic molecules can form without life, and the structures in these meteorites could be the result of non-biological processes. Curiosity rover's strange discoveries. NASA's Curiosity rover has made several puzzling discoveries on Mars. At Vera Rubin Ridge, the rover found stick-like structures in sedimentary rock that resemble ichnofossils, trace fossils created by ancient life on Earth. These structures remain unexplained, though they could be the result of geological processes like cracking or crystal formation. Curiosity has also detected methane in Mars's atmosphere. Methane is a gas often associated with life on Earth, but it can also be produced by geological processes. On Mars, methane is quickly destroyed by ultraviolet radiation, so its presence suggests an ongoing source. Some scientists believe that methanogenic bacteria deep below Mars's surface could be producing the gas, while others argue that it could be the result of geological activity. The case for microbial mats and geysers. On Earth, microbial mats, layers of bacteria and other microorganisms, are common in shallow water environments. These mats can fossilize, leaving behind structures like roll-ups, domes, and pits. Curiosity has found similar features on Mars, raising the possibility that microbial mats once thrived there. Another intriguing phenomenon is Mars's geysers, which erupt from the planet's southern polar cap. These geysers release water and carbon dioxide, and they are surrounded by dark spots and channels that could be the result of microbial activity. However, these features could also be explained by non-biological processes. Is there life on Mars? The evidence for life on Mars is tantalizing but inconclusive. From the Viking experiments to Martian meteorites and Curiosity's discoveries, there are many hints that Mars may have once been, or may still be, home to microbial life. However, without definitive proof, the question remains open. As we prepare to send humans to Mars, it's more important than ever to answer this question. If life exists on Mars, it could pose risks to astronauts or to Earth's biosphere if brought back. Conversely, discovering that life once existed on Mars, or that it originated there and spread to Earth via panspermia, would be one of the most profound discoveries in human history. It would fundamentally change our understanding of life's origins and our place in the universe. The race to Mars. Mars continues to captivate our imagination, not just as a potential second home for humanity, but as a window into the origins of life itself. With missions from NASA, SpaceX, and other space agencies on the horizon, we are closer than ever to uncovering the planet's secrets. But as we prepare to take this giant leap, we must proceed with caution, ensuring that we explore Mars responsibly and with a clear understanding of the risks and rewards.